Okay, in question 3 of part 3 of the data analysis project, I'm asking you to conduct a multiple linear regression, so a multiple regression now. Up to this point, we've only been talking about and looking at regression models with one explanatory variable, but one of the nice things about regression is that you can include multiple explanatory variables, and the regression model tries to kind of tease apart the effects of the different variables. So it gives you the effect of one variable, or the relationship with one variable uh, holding the other variables at a constant value. That's kind of how you can interpret it. But anyways, I'm going to go through how you actually conduct that multiple regression in Excel, and this will only apply to uh, people that have the data analysis tool pack for Excel for PC, Excel for Windows. So if you don't have the tool pack, or if you're not using Windows, then look at the other video on how to conduct multiple regression for a Mac. So the first thing that we need to do here is to make sure that all the explanatory variables that we're going to include in the model are right next to each other, that the columns are right next to each other. So I'm going to take my categorical explanatory variable, the indicator variable I created here, and I'm going to make sure that it's right next to the other variables I'm going to include. So in this case, I'm going to include the gas price variable. Make sure you include that same variable from question 2 when you conducted a regression with just one explanatory variable. And I'm also going to include this public transportation supply variable and then my indicator variable. So I'm just going to cut and paste this over here, insert cut cells. So now these three variables are the ones that I'm going to include as explanatory variables in the multiple regression model. So the next thing to do is go to the data tab at the top, click on the data analysis tool pack icon and select regression, just like you did before. But now we're going to want to, for our y variable, this will be the same actually, select the same response variable that you've been looking at. And then for the x variable, for the explanatory variable, you're going to select all three of those variables. So select all three columns, including the headings, the variable names, and then make sure you click this labels box so that it recognizes that those first cells are the names of your variables, and create it on a new worksheet. And then if we click OK here, we get the results. And the thing to notice here, so in part A of question 3, I'm asking you to report the regression equation in R squared. The R squared shows up in the exact same spot. It's slightly different. It can't be obviously interpreted directly as the squared, or it can't be calculated as the square of the correlation, because now we've got three variables, so we don't just have one correlation with the response variable, but it can be interpreted in the same way as the proportion or the fraction of variation that's being explained by the whole regression. So 0.4587, that's about 46% of the variation in commute percentage that's being explained by this regression. So that's where you find that R squared value right here in the same place. And then the coefficients are also in the same place. You just have to keep track of which one goes with which. So I'm going to actually write this out down here. Equation, okay, and that's going to be commute, that's my response variable, equals the intercept, negative 1.38, about, it looks like, negative 1.38, plus, and you might see a variable like this or a value like this if you have a variable with very large values, or very different values from on a different scale than your response variable. So this is just in scientific notation. You can just write it the same way that they have it here, 2.56 e to the negative 6. And that just means, if you haven't seen that before, that this is actually has 5 zeros in front of the 2, so it's 0.000000256. But it's just a shorter way of writing that. And then make sure you include the names of your variables so you keep track of which coefficient goes with which. And then the second one, 0.015 for gas price. Plus 0.49 times west. And remember that west variable, that indicator variable, only takes values of 0 and 1. So when you're interpreting that, basically this coefficient is the change in the response variable when you go from 0 to 1. So for cities that aren't in the west compared to cities that are in the west, you get this 0.49 increase when you go to cities that are in the west. So that's how you write out the equation. So that covers part A, and we'll look over part B in another video, because that actually works the same way on PCs and Macs. But this is how you report the equation. You can either report it in the spreadsheet or in your write-up. Either way will work. Just make sure you include the variable names.